Good morning and welcome back to the last section, Chapter 10. In this section, we're going to be solving nonlinear systems. So we're going to have a combination of our conic sections, and we're just going to see where they intersect. So, to start out, let's look at our learning targets. In fact, learning targets, we only actually have one. I can solve systems of equations in two variables that contain at least one second-degree equation. And so we'll have at least one x squared or y squared or both. So before we get to how to solve them, let's look to see about the solutions. We know that the solution to a system of equations is the intersection point. So let's see what can happen. With two lines, if we have, I have a little video going here, we have two lines, they can either intersect in one place, or they could not intersect at all if they are parallel, or the third option is they could be the same line. And so if they're the same line, they intersect an infinite number of times. Well, with conic sections, we don't have just 1, 0, or infinite. So let's start out with a line and a parabola. So notice a line and a parabola can intersect 2 times, but there are other options here too. They can intersect 1 time, where it's tangent, or they could not intersect at all. So here our options are going to be 2, 1, or 0. Well, what if we have two conic sections, like a parabola and an ellipse? So already we can see that it intersects in 2 places, but what are some other options? It can intersect in 1 place, there, or more often with what we'll be doing, it would be up there. It could not intersect at all. Over there, it could not intersect at all. Over there, it could not intersect at all. A lot of places. Another way it could intersect 2 places if it was tangent on both sides. That one's kind of fun. We can also intersect in 4 places. Notice we have 4 intersection points here. And so we have 0, 1, 2, 4, and it's also possible to intersect in 3 places if we're tangent here, and then it intersects both ways getting out. And now this was with an ellipse and a parabola, but you get the exact same options with ellipses and circles, 2 ellipses, hyperbolas. Any 2 conic sections can intersect 0 times, 1 time, 2 times, 3 times, or possibly 4 times. Most of what we'll be doing, it'll be either 2 times or 4 times, because you'll see a lot of them are going to be centered at the same place, just because this is our introduction into this, and so the problems won't get too horribly hard. So, how are we going to solve? Well, we have 3 methods of solving systems. The first, by graphing. So if we have 2 equations, we have our system, y plus 3x equals 0, and y minus 6 equals negative 3x squared. When we graph, a lot of times we like y equals, and hey, both of these, it's possible to get y equals, so we can subtract the 3x over, add the 6 over, and we get y equals negative 3x, and y equals negative 3x squared plus 6. Now we just need to graph these. Well, with a line, that's really easy. But with a quadratic, are we going to graph this parabola accurate enough to be able to use graphing to solve the system? Probably not by hand. So when you're solving by graphing, they will be able to be put into y equals pretty easily. Use a graphing calculator. So to do this, we just pull up our graphing calculator, and we can go to y equals, type in our equations, negative 3x in the first one, and negative 3x squared plus 6 in the second one. And then we can graph it. And so the first one coming down is a line. And the second one's going to be a quadratic. And so we can see intersection there and down there. So we should have 2 of them. And so to find it, we're going to go to the calc menu, that second trace. Notice number 5 is intersection. This is a great tool that hopefully you've been using before. It's going to ask some questions. First one's going to ask about the first curve. It's on one of them, so enter. It asks for the second curve. Notice it jumped up to the other one. Enter. And then a guess. Just put it kind of close. This is how we can tell it which intersection point we want. Hit enter. Hey, -1, 3 is our first intersection point. And then we can do the exact same thing. Second calc, down to number 5. Just push the 5 button. First curve, it's there. Second curve's the red one. Guess. Move it over to the other intersection point. Hit enter. And hey, 2, -6. And so we're able to find our 2 intersection points of -1, 3 and 2, -6, not 2 - 6. There's a comma here underneath my red pointer. You just can't see it unless I move my pointer, but it's stuck. And so we can solve by graphing. Now this works here, but would this be super effective with our non-function conic sections? Probably not. And so we do have our other 2 options. We're going to use substitution and we're going to use elimination. First, let's look at solving by substitution. So we get an equation, y plus x equals 17, x squared plus y squared equals 169. So y plus x, what kind of a thing is this? It's a line, right? There's no squareds. Then how about x squared plus y squared equals 169? A circle. So we have a line and a circle. So thinking about a line and a circle, it could completely miss. It could be tangent, intersect 1 time, or it could intersect 2 times. So we'll have to see. So with substitution, we're going to solve for x or y. I would use the top equation. Solving for x or y in the bottom equation is going to be unpleasant, and is going to lead to much more unpleasantness when you substitute it into the other one. But in the top one, solving for x or y, we just need to subtract one of them. And really it doesn't matter which one. And so subtract the x. Y equals 17 minus x. Then we plug the y in down here. So we'll have x squared plus 17 minus x squared equals 169. We need to square this out and know that it's not 17 squared minus x squared. Don't be that guy. That still doesn't work. We do have to distribute to get 289 minus 34x plus x squared plus this original x squared equals 169. Now this is just a quadratic equation. We've solved quadratic equations before. We're going to combine our like terms and make it equal to 0, so we'll have to subtract the 169. So you get 2x squared minus 34x plus 120 equals 0. And now how do we solve a quadratic? That's right, the F word, factor. So first let's factor out the 2. When we factor out the 2, we get x squared minus 17x plus 60. Now we just need 2 numbers that'll multiply to give us 60 and add to get us 17. Not 15 and 4, not 6 and 10. How about 12 and 5? Yes, 12 times 5 equals 60. And they're both going to be negative. So we have x minus 12 times x minus 5 equals 0. Which means either 2 can equal 0, but 2 won't equal 0. It'll equal 2. X minus 12 equals 0. Or x minus 5 equals 0. If x minus 12 equals 0, that means x equals 12. And if x minus 5 equals 0, it means that x equals 5. Now we just need to plug these back in up here. I would plug them into the line because you know that these points will be at exactly 1 point on the line. On the circle, these x values will give you 2 different y values. So plugging it on the line is going to be more beneficial. So we have y equals 17 minus 12. So y would equal 5. So we have the point 12 comma 5, and if we plug in 5, 17 minus 5 is 12, so y could equal 5 comma 12, or the point could be 5 comma 12. So we have 12 comma 5 and 5 comma 12. Remember to plug them in x comma y. That's one of the biggest mistakes in doing these. People plug them in whatever order they get them in. It's x comma y. So let's look at another substitution question. We have x plus 2 equals 1/8 y squared, and x squared plus y squared equals 100. X plus 2 equals 1/8 y squared. What kind of a conic section is this? Parabola. And then x squared plus y squared equals 100 would be a circle. So we have a parabola and a circle. So we could get all the way up to 4 different intersection points. So we're going to solve by substitution. Now, a lot of people will take this, subtract the 2. It's like, hey, we almost have x, right? Subtract the 2, we get x equals 1/8 y squared minus 2, and they plug it into there, and you have to square that, and that gets really unpleasant. You end up with a y to the 4th and a y squareds, and that's awkward. Instead of doing that, I'd multiply by 8. So you get y squared equals 8x plus 16. Well, here's y squared. Here's y squared. Just plug the 8x plus 16 in for y squared right here. So you get x squared plus 8x plus 16 equals 100. We don't need to solve all the way down to an x or a y. Chances are we have x squared or y squared. Solve to that. Plug it in. Well, we have a quadratic again. That's going to happen pretty much consistently here. Subtract the 100 to get x squared plus 8x minus 84 equals 0. And then we need to think of 2 things that'll multiply to give us 84 and subtract to give us 8, since that 84 is negative. So I know the quadratic formula is there for you if you need it, but all of these questions, I don't think I'm missing any. Pretty much all of them should factor. You should get nice numbers. Might be more difficult though. I know I first started thinking about 84. Well, that's 21 times 4, but that's not going to get 8. But that factors. 21 is 7 times 3. Well, 3 and 4 is 12. 12 and 7 isn't going to get 8. But 4 is also 2 and 2. How about 7 times 2 and 3 times 2 to get 14 and 6? Aha. That will subtract to get us 8. So x plus 14, x minus 6. If we multiply, 14x minus 6x is 8x, and 14 times negative 6 is negative 84. I'll wait for you to check that on your calculator. I know you want to. Yeah, 14 times 6 is 84. So that means that x plus 14 equals 0, or x minus 6 equals 0, which means x could equal negative 14, or x could equal 6. Let's plug it in. Let's plug in negative 14. I would plug it into the one that you don't have both things squared. Because when you square things, weird stuff happens. So if you have a parabola or a line, plug it into those. So if we plug negative 14 in here, we get negative 14 plus 2 equals 1/8 y squared. Negative 14 plus 2 is negative 12. Then we can multiply by 8 to get negative 96 equals y squared. But y squared is always going to be a positive number. So this isn't going to work. This would have worked if it was going the other direction, if the parabola was going the other direction, but it is not going to work here. Because, again, the negative can't be squared. If we were to plug it into this one, we'd square it, and we'd end up with 196. And we'd subtract, and we get y squared equals negative 96 again. So in that case, it actually wouldn't have worked in either situation. But, again, I'd always plug it into the one where it's not squared. So let's plug in x equals 6. I'm going to plug it in here where we've already multiplied by 8. We could have done that here. I just didn't want to do negative 14 times 8 to get something bigger than 84. So let's plug in the 6 here. 8 times 6 plus 16 is 64. So y squared equals 64, which means y could equal plus or minus 8. Don't forget, when you square root both sides, you get plus or minus. That's how we get our multiple solutions. So our answers here, we could be at 6 comma 8 or 6 comma negative 8. And yes, you can write that as 6 comma plus or minus 8, but you do have to realize that it does mean both of these points. So we do have two solutions here. So that's solving by substitution. All right, now let's look at solving by elimination. This is always my favorite. So if we have x squared plus y squared equals 20 and 4x squared plus y squared equals 68, how do we do it? Oh, I say it's my favorite. Doing the lines, a line in a circle, elimination is very, very difficult. So I wouldn't do that. You want to have at least one thing squared. So, solving by elimination, it's going to be easy to get rid of the y squareds. We just have to make one of them negative. So let's multiply that top equation by negative 1. And we can distribute it. Negative x squared minus y squared equals negative 20. Add these together. Negative x squared plus 4x squared is 3x squared. The y squareds go away. Negative 20 plus 68 is 48. We can divide by 3 to get x squared equals 16. And square root to get x equals plus or minus 4. So plus or minus, is that going to matter? Both places we'd plug it in is x squared. And so either way we plug it in, it's going to become positive. So x squared equals 16 is the important piece here. So the plus or minus, we're going to have both possibilities there. So let's plug it into one of them. I'd recommend the top one because that's the easier one. So we have 4 squared plus y squared equals 20. 4 squared is 16 plus y squared equals 20. Subtract. Y squared equals 4, which means y equals plus or minus 2. And again, both y's are squared in each equation. And so the plus or minus doesn't make a difference if it's positive or negative. It's still going to give us 4. And so here we have 4 answers. We have 4 comma 2, 4 comma negative 2, negative 4 comma 2, negative 4 comma negative 2. And yes, you can write this as plus or minus 4 comma plus or minus 2, knowing that that gives you 4 answers. What people do is they get these two middle ones where there's only 2 solutions, 4, negative 2, and negative 4, 2, and they try and write that as plus or minus 4, plus or minus 2, and that does not work. If you had just these two middle ones, you'd actually have to write them out separately. So, but we have 4 solutions here, plus or minus 4, plus or minus 2, which if we look at the equations, x squared plus y squared equals 20, that's going to be a circle. 4x squared plus y squared equals 68 is going to be an ellipse. And so it would make, and they're both centered at 0, 0. So it makes sense. We have a circle and an ellipse. It's going to hit in 4 different places, symmetrically even. All right, let's do one more. 9x squared plus 5y squared equals 45. 6y squared minus 27x squared equals 54. So we just need to make one of our variables the same. And at first look, it looks kind of obnoxious because 9 and 6 and 5 and negative 27. But when we look at the variables. X squared, y squared, x squared. Hey, here's our x squareds. Well, 9 and negative 27 isn't that bad. We just need to multiply that top one by 3. And then I'm also going to rearrange the bottom one to put them x squared first and then y squared. Hyperbolas do this. Make sure you put them with the variables in the right place. Otherwise, the addition can go very, very badly. So when we multiply by 3, we get 27x squared plus 15y squared equals 135. And just the rearranging, negative 27x squared plus 6y squared equals 54. We can add them together. The x squareds go away, which is by design. And we have 15 plus 6 is 21y squared equals 189. Divide by 21, y squared equals 9. So y equals plus or minus 3. Notice all the y's are squared, so the plus or minus, it doesn't matter which one we plug in. So let's plug it into one. I'd plug it into the top one, just because the numbers are nicer. So we have 9x squared plus 5 times 3 squared equals 45. 3 squared is 9 times 5 is 45. So 9x squared plus 45 equals 45. Subtract. 9x squared equals 0. We divide by 9 to be 0. Square root. X equals 0. So our answers are 0, 3 and 0, negative 3. Or 0, comma, plus or minus 3. So here, it ended up being just 2 solutions because it hit 0. If this was a number, we would have ended up with 4 solutions again, because we have an ellipse and a hyperbola, and so it just happened to hit at the vertices. But if it didn't, we would have had 4. So this one's kind of a cool one to draw, because you have the ellipse here and then the hyperbola going each way on the vertices. Yeah, they're just kind of fun. We'll actually be drawing some of these systems and making art with them later on this week. So anyway, that's solving systems. There isn't much new here. It's just using what we know, and hey, now we have squareds, and we're going to end up having to solve quadratics, but that's okay because we've done this before. So, but we're solving by graphing a little bit, but mostly solving by substitution and elimination. Anyway, I hope you have a great evening, and I will see you in class.